Hello and welcome everyone. My name is Riju and I'm a cloud solution architect at Microsoft. I'm going to talk about Azure Kubernetes service today. So essentially what I'm going to discuss today is how you can create an AKS cluster in Azure and then connect that and then finally deploy an application to that AKS cluster. So let's see all in the demo. Let me open my browser. Let me log into the Azure portal. Now, when you create an AKS cluster in the real production, you basically use it via CI/CD pipeline. But for the demo purpose, I'm going to use the Azure portal, which is easier for us to navigate and go through. So I'm going to go ahead and create a new Kubernetes cluster. So if you don't see it, you can always type Kubernetes and that gives you the Kubernetes service. So this is the real Kubernetes running on Azure as a fully managed service so that you don't have to maintain and manage the Kubernetes by yourself. Otherwise, you need a different skill set and the capability to manage it. Now you see here, this is the subscription I'm in. I just wanted to create a new resource group. Maybe I'll say RG AKS. And then the resource group will be created as soon as I create the AKS cluster. Now, AKS cluster does provide you a couple of pricing options depending on what kind of workload and what do you want to do that. So since I'm only doing it for demo, I will choose dev test, but for real production and secure one, you will select different options. Especially the one I wanted to talk about is the hardened access, which means the images will be hardened by the CIS. And you can see that it gives you additional benefit like having to have that image safe and secure. So let's choose the dev test. And then I give a name and you choose the location or the region of the Azure. So there are 50 plus. And I don't want this availability zone, so I will not select it. You can choose the version. Now, just to let you know that Kubernetes version is the upstream Kubernetes version here we are discussing about. So any given point in time when you have a specific version available in the upstream, it gets onboarded into Azure after certain amount of testing just to make sure that everything is working perfectly fine. Hence, we release it or make it generally available. Before that, you see this preview. This essentially does not mean the Kubernetes in the upstream, which is open source Kubernetes, is in preview. It is probably released, but in Azure, we are yet to recognize it as a generally available feature, which means that you are just warned not to use it for production if you are planning to use it. So use something which is not in preview. So you can see that 1.24.6, the default one is always 1.23.122 version before. So you can choose whichever you feel like. So I'll just leave it the default one. And you can select the availability of your Kubernetes cluster, right? The API server availability. So the API server is important because that is how you will interact with the Kubernetes server from your application deployment perspective. So I'll select the 99.5% for the demo purpose. I don't need that. Automatic upgrade is an interesting aspect. So you see that I have selected 1.23. Do you need a patch update? So when, let's say, 1.23.13 is coming, that's the patch version, the last part of the system code. So that is the semantic of 1.2 becomes 1.3.1.4. So those are basically patch. So do I allow the patch update to happen automatically? Here it doesn't say that from 1.23 to 1.24 upgrade will happen. So you need to make sure what you are selecting. So you're not allowing the Kubernetes cluster or Azure to auto upgrade the minor version. So we are allowing only the patch. So patch is always recommended, and it is just a layer on top of existing one, so it doesn't change the existing system, so it will not impact anything as such generally. But it is always recommended that you should go ahead and test it before you finally deploy it in the production. So what is the scaling options? I'll choose manual. Scale means the number of nodes which is running behind the Kubernetes cluster will scale depending on the load. So I'm not going to do that. What is the node size? You can change the node size. So you can see that it's using standard B4MS, which is recommended for dev test, but you can always change the size. If I've chosen something different in the list of types you have seen in the SKU, the standard hardened, it will show you different images, but that doesn't stop you to select a different node image um, SKU. And then I say that node pool, so you can add additional node pool. So by default, the agent node pool will have Linux operating system with 3 nodes. If you are running Windows container in Windows operating system, you need Windows node pool, Windows user node pool. So you will add that Windows user node pool over here at this point in time. Do you want a virtual nodes? This is an interesting aspect. You don't really need the node pool. What will happen that every time you create a pod, it will get deployed in the Azure container instance, which is basically set up virtual machines available for you, but you don't get to see them, neither you know about it, but we can use it for additional capacity if we need so. What is the encryption? So is it managed by you or something else? So what is authentication and authorization for your Kubernetes? Do you need an Azure Active Directory authentication authorization or the Kubernetes internal certificate-based authentication and authorization system? Do you need Azure authentication with Azure RBAC, right? Or Azure authentication with Kubernetes RBAC? So different depending on how the cluster management would look like for you, who once you want to give access to and how do you want them to restrict that access. So all these things depends on this selection. So if you choose the local account with Kubernetes RBAC, all you need to do is that you need to create the setup certificates. Those are the users. Kubernetes doesn't have a concept of user. Account means certificate, so you will use those certificates. So I'll choose the default Kubernetes one, and you can select depending on what is your need. Network is important. So sometime like if you're using Azure CNI for Kubernetes, you need the networking in place. So I'll not select that. I will rather select KubeNet. It's for demo, right? So it's okay to use Kubernetes. Otherwise, the Azure CNI does give you additional power like monitoring, like providing the firewall rules, allowing IP ranges, allowing certain ports, blocking certain IP addresses, blocking certain ports, etc. will be much more flexible and easy to configure in Azure virtual network because it's the core Azure virtual network which we have been using for ages. So I'll choose Kubernetes, easy option, and then I'll go with the integration. So do you have an Azure container registry from where you want to download the image, your private registry? You can delegate that so the user for Kubernetes will be able to access the Azure Container Registry. There'll be a delegation happening. All these things you can do even later after the cluster is created. So this part, which I'm showing that Container Registry Association can happen later point in time also. Do you want to enable Azure Monitor for container monitoring? So which will allow you to have the container insights and overall data being stored in your monitoring mechanism, which you can later point in time query, create a dashboard, and etc. Right? So and then it is definitely a bit of charge will be there because you are transferring the data and storing it to something. Do you want to apply Azure policy to restrict certain types of activity within the management aspect? Then you should enable that. We're not doing that. Let's go ahead and create next. And this is going to create another resource group, right? I have created one resource group called RGAKS. This is the new resource group, but this will create another resource group where the node virtual machines will be lying. So whenever you create any additional virtual machine, that will be landing in this. So you can change the name. Earlier it was not allowed to change this name, but now it is allowed to change the name. Do you want to create Kubernetes secrets for your application, which will basically store your connection string, username, password kind of credentials? And then don't you like to put it in the plain and formatted text, or should you put it in the CSI driver? So it depending on where you want to store those secrets, because if you create the Kubernetes secrets, it is simply base 64 encoded string, which is easy. Anybody can just copy the string and run the base 64 utility in Linux to decrypt it, and it will be clearly visible. So it is not, let's say, what do we understand by encryption? It is like sort of distorted text, very easily can translated. It is not an encryption, real encryption. So secret is not really a secret. Maybe it's not human readable on the first glance when you see it, but you can just do a little reverse engineering to retrieve the plain text. So sometimes it's not recommended in the real production. That's why it is important that you don't use the default Kubernetes secret storing mechanism using base 64 encoding. And then I'm going to use this. Now, once I'm satisfied with all of them, I will go ahead and say review create and hit the create button, which will take some time to create the whole thing. After the validation is done successfully, whatever I've selected have all the rights to create, resources are available, and all these things are part of this validation. If I hit the create, then it'll start creating. While it is getting created, I want to walk you through some of the important aspect of working with Kubernetes. One is you need a tool which will help you connect to the Kubernetes cluster and then do the API server connectivity. So let me show you that part. So if I go ahead and say Cubectl, that's the utility I was referring to. It's a CLI based command prompt, which is the first step towards getting Kubernetes working. So you can see that the Cubectl is a tool available, and it also will have an option to share how to install the thing, right? So how do you install the tool, right? And how it really works. All these are documented over here. There is a nice little documentation called Cubectl cheat sheet, and that will tell you like if you are using it very frequently, what all configurations you will be doing, etc. So we will look into that later point in time. But this is the tool you need for the Kubernetes to work. So if you want to know how to install it, say install. Depending on where you are installing, it gives you a good amount of information. So I'm going to use my Windows subsystem for Linux, and that's where I'm going to use this tool. So I will go with the native package management. I'm using Ubuntu in my WSL, so I can use the Debian based distribution. If you're using something like Red Hat or CentOS, so you will select this option and follow the instructions. It's very simple and straightforward. So you just have 4 steps to follow, and once you follow all the 4 steps, that will be clearly available. So let me show you my um, terminal. So I'm using Windows Terminal, which allows me to connect to my WSL, which is already configured. You can use anything. You can use a PowerShell, anything of that sort. So let me go ahead and make it. So this is my WSL, and I'll show you the Cubectl, which is already installed. Comes up like this if you are using it. So what I'm going to do is that I'm going to create an alias. This is part of the cheat sheet guideline, which says that every time you don't have to type the full command, just type K and it works. So instead of typing kubectl, you will type K. So that's what I'm doing here. Now I'm going to actually create, split the tab this side, where this will be basically showing me the list of things which I will be working once this Kubernetes cluster is ready. So it's saying deployment is in progress. So if I go to my home resource groups, I'll be able to see that there is a new resource group got generated. The, the cluster is kind of getting created. So probably the virtual machines are getting now deployed. You will eventually see all the things related to virtual machines, load balancer, everything will come up here. So that's the thing which is getting deployed at this point in time. So we'll wait for a few moments while this notification notifies us that deployment is done, and then come back to that. Now, a couple of things we might need over here is we'll be using some container image to deploy, right? So we'll use Docker Hub to get the container image. So Docker Hub does provide a lot of container images for free. So I have a user account where I have my own container image, which is modified by me. So you'll clearly see the difference if I use one of these versus what is Docker Hub provided one. And I will quickly, while this is getting created, I'll quickly walk you through some of the activities I'll be doing. So what I'm going to do is that I'm going to go ahead and let's say use my Docker. So let me see if my Docker is running locally, Docker CE. So if it is not running, then just say sudo docker d. So I'm just going to start the Docker daemon locally. And once this is done, it should be up and running. So it's fine. So this is what I'm going to do, right? So I'm going to go ahead and say Docker run hello world. That will basically be running the hello world Docker, downloading the hello world Docker from the Docker Hub. And then I say Docker PS. I'll not see that because it got exited. I will say yes. Then you will see that hello world Docker was there, created 9 seconds ago, and now suspended, right? So let me reduce the font size so that you see it in a better view. So you can see that it's exited. So I can delete the other one. That's Docker RM this, and it's gonna go ahead and clean. And then you can see that the only one hello world got suspended 37 seconds before. So that's where I'm going to use. So what I can do, I can say Docker run, and I will use something called -d. That's called detach or daemon mode. And then I'm going to use nginx. That's the image, right? So this, if I say so, then the Docker will be running for me. So you can see that now one live container. If I say -a, then I'll see two of them. So this means that now my Docker image is running, but I cannot really access this because I need to then configure the network and all these things. So instead of doing that, what I'm going to do is that I'm going to go inside that Docker container, exec -it, name of the container. Maybe I'll pick the container ID instead of name because I didn't really provide any name. And then I'll say that I'm gonna go into the shell command. And I know this is an nginx which has got a local host. It's a web server for static files. So I'll say local host, and it should show up some HTML, raw HTML, because it's in the console, right? So if you go out of the container, that means it is fine. I'm going to use this image to build something in my Kubernetes. But let's see before that if my Kubernetes is ready. It is ready. Let us go here into that resource, aka SWG, and let's go into this connect option. This helps me connect, gets the certificate downloaded locally into my WSL. So I copied that and I pasted it. So the condition is that you need to be logged in from this console through Azure CLI. So essentially, you should be running AZ login that will prompt you to log into the browser and connect back. So CLI is now connected to your Azure subscription. You need to make sure the subscription you are working with is the default subscription. So for that, there's a previous instruction, so which is already, I think, the default subscription. And then you run the second one, which is to get the certificate downloaded from the Kubernetes cluster to your local configuration, that is .cube/config, right? So that's where it is going to get saved. Okay, it's a text file contains the thumbprint of the certificate. That's where when you say k get pod, if you say that, then it's going to go ahead and say that there is no pod. That means it is now connecting to that cluster. Now I can create a pod. And to create a pod, I can simply run a few things. So let me go ahead and close this. And how do I remove this? Maybe if I close the tab, it does close everything. So I'll say that terminal again, terminal, and then in that terminal, I'm gonna just use the full screen. What I am going to do now is that I'm gonna create a pod. So I'll have to use the alias k kubectl, and then I will say k run where nginx image nginx. Okay, if you have a specific registry, you have to provide the fully qualified URI, but I'm just using the default one. So it is coming from some public registry maintained by someone, but that's a standard nginx image. So now I have got a pod running in this local cluster. So you'll see there is a pod running. Earlier there was nothing available, so it is running just 14 seconds ago. It got created and it is running. That's fine. But this is not how you deploy an application. So you deploy an application in a different way. So let me show you that option. But before that, let me also open up this split tab. Keep this running. K get pod -w. It is basically an option to watch what is running or happening with my existing set of pods. So if I just simply run this command again with a different name, maybe nginx1, you will find another pod is getting created. And once it is kind of done, it'll show you running. So right now I have two, but this is because this is a log stream. You will find a lot of entries, but actually there are two pods running. If you simply say k get pod, you'll see the two pods running, right? So let me clean that up. And then say nginx1. So I delete both of them. So you'll see that it's getting terminated. So it's gonna go ahead and get over. So let me clean this up and run this watch again. So right now there is no pod, so it is not going to display anything. I'm going to create something at the Kubernetes called deployment, because Kubernetes has an auto healing capability. We don't deploy an application in a pod, but we deploy it in a deployment. That's an object in Kubernetes. So I'll say k create deploy. That's a command we use, and we give a name. So I'll say nginx. That's a name, and I'll use the image nginx. And that's going to go ahead and create a pod for me automatically. Deployment can have more than one pod running behind the scene. It acts like a load balancer and keep observing all the pods under it. If I manually delete any one of them, it'll go ahead and recreate that without me intervening into it. Okay, so that's a kind of model we have. Now, this is running a pod under this deployment. What I'm going to do at this point in time is that I'm going to go ahead and create a service. Then service basically allows me to get an IP address And in the context of cloud, when you are using public cloud, which manages the Kubernetes, the public cloud provider do use something called Cloud Controller Manager, which basically helps you get the get the public IP from its load balancer. So it uses their default load balancing capability. So let me create that. So I'll say k expose deploy nginx, and then I'm going to use the port 80. And then because nginx control container uses port 80 internally also, I don't have to define a target port if it is the same. Otherwise, if it is using like something else like 5000 or 5001, I have to say target port 5000. Then I will say type, and this is the key here. Type is load balancer. This part of the command will not work if you use it outside of the cloud context. Okay, this is coming from the Cloud Controller Manager of Kubernetes, which is specifically done by the cloud provider. Now, if I run this k get svc minus w, you'll find a new nginx with created with an IP address visible here. So I can use this public IP address to do a curl. So if I say curl and then enter that, what it's gonna do is that it's gonna go ahead and get the page from the container which is running inside my Kubernetes cluster as a pod behind the deployment exposed via this service. That's how it looks like. Now, just to show you the real page which is running actually accessible via public IP address, is this is the page. So if you're using any nginx thing, you can definitely do that. What I'm going to quickly show you is that I'm going to quickly replace this nginx image with something else. So I'll say that delete deploy nginx. Nginx deployment is deleted. Now I'm going to use the previously created deploy, but this time I'm going to use the nginx image from my registry, which I just uploaded yesterday. And you can see the deployment is created. It is mapping to the same IP. I don't have to create that because they're loosely coupled. And if I just go ahead and simply refresh it, it shows you different page, not the previous page, because I just replaced the container with my container, which I have created yesterday and modified it. So that's how you see the difference of how you can run a simple web application, deploy it in the AKS cluster by running the kubectl command in the Kubernetes concept. Thank you very much. Hope you have enjoyed it.